Kia ora, welcome back to the next section. So we've finished with hardware timers, and we're going to have a look at hardware interrupts now. So I want you to think about the fact that, again, we're focusing on the big issue here. What is the big point? And that is to make our system responsive and reactive to the real world. Because the code that's running inside a microcontroller has little way of interacting with the real world, apart from doing something perhaps like polling. And so that means checking switches regularly to see if someone has activated a switch. Alternatively, now you know about timers, so that means that you can, on a timed schedule, you can check things in the real world, or actually you can measure things quite accurately that are happening in the real world. So these are the sort of things that timers give you. But what about if that thing that's happening in the real world doesn't have a regular basis to it, so it's untimed, and perhaps it's urgent as well? And so this might be what we would call asynchronous. It's just something that can randomly happen whenever, but has no regular timed schedule. So we would have to poll our switches, for instance, to check to see if they had encountered an input. Now, that doesn't work when our code gets unwieldy and large. It becomes very difficult to check our switches, to poll them as often as we perhaps would need to. And so instead of trying to add more polling tests into our code, we take them out of our code completely, and we implement this sort of feature using an external interrupt pin. We have a couple of those on the AVR that we're going to look at. Now, what's going to have an example here is I'm going to take a situation where you've got an LED which is giving a double flash every 2 seconds. So it's on for a very short period of time, off for a very short period of time, then on for a short period of time, and then off for 1.7 seconds. So in total, you can see that the delay here is 2 seconds. And this delay function is what we term a busy wait. We're just spinning wheels. The microcontrollers, all it's done is it's got this huge number, it's subtracting 1 from it as fast as it can, which will still take a long time if it's a very big number. And then when it's finished doing that, it will jump back into the code again. So think about if you pass 100 as a parameter to this function, it's going to multiply it by some factor, and then it's going to over a period of time, it's going to delete 1 from this number, check to see if it's 0, and then delete 1 from it, and continually do this. So if this is a very large number, it's going to take a long period of time. And so while the microcontroller is in this state, it can't do anything else. We've passed control to that function. We can't poll switches. We can't do other things in code that we might want to do. So again, we've got to find a way to avoid this. Now, if I was polling a switch in this loop, then the poll of the switches might happen here, for instance. So we've got a whole period of time. We've got 2 seconds before the switches are polled. Let's have a look at the actual code. I've done this code. So here we have it. We've got this flashing, and there's the toggling of the LED when the switch is pressed, okay? So if the switch is held low, we toggle the LED. Of course, this only happens every 2 seconds. So let's have a look at this. I've actually got the code running. I know it's a very small image up there, but I'll just pop this up in front of the camera, and you hopefully will see the double flash of the yellow LED and the period of time that it's taking. So it's just that double flash every 2 seconds. Now, what that looks like, of course, if I was looking at that in an oscilloscope, and I've got that captured in my oscilloscope now, I'll just bring the scope trace over to here. And what that looks like, of course, is the LED comes on at this period of time, then it goes off for a short period of time, then it's on for a short period of time, and then it's off for the 1.7 seconds. But of course, our switch is only checked during this tiny little portion of code just here, just at that period of time. So for instance, it might be just, check the switch only takes a couple of cycles of the microcontroller. Everything else is taking 2 seconds. So we are only ever checking our switch this often. This is clearly unsatisfactory. All of the rest of this code, all of the rest of it is just blocking our microcontroller from being able to check our switches. So that's a very long period of time. I'm just trying to get my scope to respond with my measurement here. There we go. So all of this time here, which equates to 2.01 seconds on my scope trace here, all of that time it's blocked. We're only ever checking the switch just for this tiny little period of time here before we turn the LED back on again for this first double flash. So this sort of issue of blocking code. Now, I'm using this program as an example of blocking code. I'm not saying that this is a problem with delay MS functions. Okay, it is an issue with delay MS, but it can also happen anywhere in your code where you get busy doing things and the microcontroller cannot respond in time. Now, I just want to clarify one little other error here. This shouldn't be int main void here. It should be, of course, this is the while one loop. So the thing to do is to understand that this takes a busy long time. It could be any part of code, could be doing anything. And so what we do is we actually take away our check switch functionality from the code completely, and we put it in an interrupt service routine. And we're going to go on now and have a look at how those interrupt service routines work. Of course, this ability to take it out of the main loop makes our microcontroller much more concurrent than a normal sequential process allows. And that's really an important concept. Again, making it responsive and reactive, trying to make it concurrent. And it's almost concurrent. I'll explain why as well. In question 31 in the assignment, you're asked to take away the switch checking from the main loop and put it inside the interrupts. And so this session here will help you understand how to do that. Let's have a look at an interrupt service routine. The LED does a double flash every 2 seconds. And we're going to connect our 2 switches now to our 2 interrupt pins. And when the switch is pressed, we're going to have the code jump into a little function, another ISR, interrupt service routine. In this case, I'm using INT0 vector. It could, of course, be INT1 vector. We'd have these 2 pins on the microcontroller, which are INT0 and INT1, which allow us to set up switches or other input devices, for instance, maybe a micro switch, which is connected to a machine. So if the machine goes out of bounds, the software knows immediately that the machine has moved away from where it's supposed to be and immediately does some special shutdown function in the code. There's all sorts of ways you can use these interrupts. Now, if we're looking at our code, it might be in the middle of a setting an LED. Now, when you think about it, setting an LED isn't a single command, okay? It is in C, but it is not in machine code. And interrupts work at the level of machine code or assembler, okay? So remember, we've already unpacked what, for instance, a simple little C program looks like that adds 2 numbers. And if you need to, you can review that. It's in one of the earlier sections of the course. Now, a set an LED takes a couple of machine code instructions. So it might be that during these couple of instructions, the interrupt happens, and the interrupts are asynchronous. They just happen at any time. They're not linked to the clock of the microcontroller. So the microcontroller just finishes its current instruction. And I'm talking about its machine code or its assembly instructions, not its C instruction. A C instruction can be large and complex, made up of multiple elements of machine code. So it will finish its machine code instruction. Then what it will do is go away and carry out what's inside this vector, this ISR, and then it will come back to the next machine code instruction after the one it was interrupted during. So it finishes its current one, goes away, comes back and does the next one. So it might jump back into the middle of our set LED because set LED is a couple of instructions. Of course, if the, let's have a look here. Let's have a look here and say it had just finished or was just finishing the instructions involved with setting the LED, it would jump away and do what's in there and then come back to the next point in the code, which would be a call into the delay MS. So it wouldn't actually jump into the middle of this instruction. Of course, this instruction can take an awful long time. In terms of microcontroller time, 100 milliseconds is a very long period of time. And so your code might be in the middle of a delay. And so our delay, of course, what it's doing is it's taking a really large number, decrementing it by 1 until it gets to 0, and it's just doing this loop continuously until it gets to 0. So it might be in the middle of a delay, a decrement of the delay value, and then it will go away and do this code in the ISR, and then it will come back and finish our current decrement, and then go away and keep going around again to complete its cycle. So this means that this function that we had, which was unavailable for us to enter and look inside while we're running our program, is now completely transparent. Doesn't matter if our switch happens during the delay, it will just stop after its current machine code instruction, jump away, come back and do what it's supposed to be doing. And you can add up here anything in terms of, you know, it's when these options are happening anywhere in this code, it will just jump away, do it, and come back to the next code. So again, just it's not a C instruction like a set LED or X plus Y. What it is it's a machine code instruction. It will finish its current one and then go to the next one. And there are some complications around that we need to think about, and I'll introduce those later on. Okay, I'm just going to pause this now and come back and do the rest in the next vid. Cheers.